Okay, so we're going to review simplifying radicals. Okay, remember radical is just the name of this little figure here. Okay, that's what we call a radical or a square root symbol. Okay. So can someone raise their hand and tell me what the square root of 25 is? Yep, 5. Because if we took a square, remember all this is finding the area. I'm giving you the area of a square, which is 25. And I'm asking you for the length and the width to make it a perfect square. So 5 times 5 will give me the 25. So the square root of 25 is 5. Any questions over that? Yes?
Why is there a line back 25?
Oh, it's because it's my cursor to start typing. Sorry. So 64, same thing. Class, what's the square root of 64? 8. Because again, if I have 64 here, the length of my sides will be 8 times 8. So square root of 64 is 8. Any questions over that? Yes? I'm sorry? I would. Okay. 24 now, this is when it becomes a little bit more complicated. Because 24 isn't a perfect square. So the area of that square is 24. What we need to find is the length of the sides that multiply to 24. And because we want it to be a square, we need them to match. In order to do that, you want to factor it. So I don't know how you factored last year, factor tree maybe. There's other ways. 8 and 3. You could have done 2 and 12. You could have done 6 and 4. It doesn't matter. Just find something that multiplies to 24. Then keep factoring until you have perfect prime numbers. So 3 is a prime number. Just like when we were factoring before, we need the sides to be the same. So we need a 2 here and then a 2 here. Leave some room for it. So my pairs I get to split into here and here. Now the 2 and the 3, I can't split and put 3 here and 2 here because that wouldn't be a perfect square. That would be a rectangle, not a square. Okay? You can't take half because we're multiplying, not adding. If it was adding, we would take half. Okay? So to make this even on each side, you're going to have the square root of 2 on this side and the square root of 2 on this side, as well as the square root of 3, and then the square root of 3 here. I'm sorry? Times. It's a times. You're multiplying. Because this is area, and area is all about multiplication. So you're not going to be adding or dividing anything. You're going to be multiplying everything. So if I multiply this all together, the 2 is on the outside. The radical 2 and the radical 3 can be multiplied to get radical 6. So the length of each sides are 2 radical 6 and 2 radical 6. You don't need to write this down, but I'm going to prove to you that 2 radical 6 times 2 radical 6 equals 24. Okay, when you multiply things with radicals, you're going to multiply the numbers outside together. So 2 times 2 is 4. And then you're going to multiply the numbers inside the radicals. Square root of 6 times the square root of 6 is the square root of 36. The 4 doesn't change. But now I do know the square root of 36. Class, what's the square root of 36? 6. And then 4 times 6 is 24, which is what I started with, right? I started with the area of 24. And I wanted to find the length of the sides. So that's how I can prove that the square root of 2 square root of 6 and 2 square root 6 are the length of the sides of a square that has an area of 24. Any questions over that? Okay. Let's do a few more just to practice. Okay, 48, same thing. We want to factor that. So I'm going to do 4 times 12. If you did other numbers, that's fine. We're then going to get 2 times 2, 4 times 3, 2 times 2. So for my square, I have this pair of 2's that goes here and here. I have another pair of 2's that I can multiply here. And then I have this 3 that's all by itself, so I can't split it. There's not a 3 for each side. So I need to put a square root of 3 on each side. That's the square root of 3 here. Any questions over that? So, the length of the side should be 2 times 2, which is 4, square root 3. Any questions over that? Okay, do the next one on your own. That's my answer, 4 square root 3. I don't have to multiply it out to prove it. I just showed you so that it is true. Okay? If you'd like to multiply it out, you can, but it's not necessary. Okay, so we should have gotten factors of this. Quiet, please. 8 times 4, 4 times 2, 2 times 2, and you have 2 times 2 over here. So I have a pair of 2's here. So it goes on the outside. I have another pair of 2's. So it goes on the outside. And then this 2 doesn't have a pair, so it's inside the radical. So the square root of 32 simplified is 4 square root 2. Any questions over that? Okay, do the next 3 on your own. Or the next 4 on your own.
4.
And those next 4 on your own. And then we'll check them.
You told me to go over that.
Yeah.
I don't know what it is.
Wait a second. Okay, Yasmin, what'd you get for F? Well, I wouldn't know, because 27 is not a prime number. So what multiplies to 27? 9 and 3. Then what? Uh-huh. 3 radical 3. Perfect. Okay.
3.
Diane, what did you get for the next one? What is it? Very good. 2 radical 14. So this would be 7 times 8, which is 4 times 2, and then 2 times 2. So your pair of 2's are right outside, and then 2 and 7 are inside, so it's square root 14. Any questions over that? 8 times 7 is 56. Yes. Diana, what did you get for H? 2 square root 3, or 2 radical 3, yes. Okay? So our factors would be 4 and 3, or you could have done 6 and 2. So there would be a pair of 2's, which goes out here. And then this 3 is inside the radical. Okay? Yep. No, John's next. John, what did you get for I? What is it? Okay. Then what?
Oh, the answer.
Oh, 2 and 2? Okay, so it shouldn't be 4 because there's a pair of 2's.
It's supposed to be 2 times.
So it's, don't multiply them because you're doing the length of the sides, right?
Yep. 2.
So one side goes here and 1, 2 goes on this side. The square root 2 is here. The square root 2 is here.
2 out of 2.
So you just want the length of the sides, and since they match, it's just 2 square root 2. Does that make sense?
Yes.
Okay, so don't multiply the pairs, because the pairs are being split up between the 2 sides of a square. Any other questions? Okay, now we just have to review adding radicals. To add radicals, they need to be like terms. They have to have the same number inside the radical. It's called the radicand. Okay, so the number inside the radical is called the radicand. Okay, an example of this is the square root of 5 plus 3 square roots 5. Okay, you need to treat the square root of 5, since it matches, as a variable. So this is like 1x, and this is like 3x's. So if I'm counting them, which is what I'm doing when I'm adding, if I'm counting them, how many radical 5's do I have? I have 1 here, right? And 3 here, right? So how many total do I have? 4 square roots of 5. Okay? Any questions over that? Okay. Now, what if I had something like this? Two plus the square root of 3. Yep. Yes? Okay, this would be like 2 plus, remember the square root of 3 is like an x, like a variable. Can you add 2 and x?
Or yeah, maybe. Or,
No, that'd be multiplying 2 times x.
oh, yeah.
Okay? So you can't combine these, they're not like terms, so you just keep it as 2 plus the square root of 3. That's as far as we can go without using a calculator, without estimating our answer. This is an exact value here. Any questions over that? So if you took your calculator, and we can kind of guesstimate, the square root of 3, what's the perfect square that's below square root 3? 1 is the perfect square, right? The square root of 1. And what's one that's right above the square root of 3? Right, the square root of 4. So the square root of 3 is in between 1, the square root of 1, and the square root of 4. What's the square root of 1, class? 1. And what's the square root of 4? 2. So the square root of 3 is somewhere in between 1 and 2. It's probably closer to 2 because it's closer to the square root of 4. Okay, so this value is kind of like 1.7, 1.8, something like that. And then we could add 2 plus whatever that is, 1.8. And then you get 3.8. Does that make sense? Your calculator will give you the exact, or give you a rounded value. Okay. This is what we call an exact value, because we didn't have to simplify it at all, or we didn't have to round it all. Okay? But it will give you an idea of what the value is. That makes sense, because if I ever told you, oh yeah, I'm 2 plus square root 3 feet tall, you'd be like, what in the world does that mean? Okay? So we want to use the estimating. Yeah, it would be short. But in algebra, they often want you to have the exact value, so we leave it like this. Yes? Can't hear what you're saying. Because that would be multiplying by this. 2 times the square root of 3 would be 2 radical 3. Which is way different. Because 2 times about a 1 point something is way different than the actual value.
Wouldn't the square root of 1 equal 5?
No, the square root of 1 is 1 times 1 is 1, right? It's not half of a number. The square root is a number times itself that gives me that number.
Is 1.
I'm sorry? 0.5 plus 0.5 is 1. A half plus a half is 1. But we're saying what multiplies to those numbers. Okay? Any other questions? These are good questions, you guys. Okay, so this was just to review because we're going to need this later in this lesson. Okay? This right here is what we're going to be doing. We're going to be solving quadratic equations. Okay? We're going to first introduce this to you by graphing it because we've been graphing for most of this year now. Okay, so we should be very familiar with it. So to solve this equation, negative x plus 3 quantity squared equals negative 4. Okay, we're going to graph both sides of my equation. So I'm going to graph this left-hand side, f of x equals negative the quantity of x plus 3 squared, and the right side, which is h of x equals negative 4. So let's start with graphing this one. It's in vertex form. Manuel, can you tell me my vertex here? Negative 3, very good, and 0. There's nothing outside for my k value, so it's a 0. So I'm going to go where x is negative 3 and y is 0, which is right here. And that is my vertex. Then we need our a value. Kyle, what's your a value?
Negative 1.
Negative 1. So a equals negative 1. So then we're going to use our pattern rate of change, which is a over 1, then 3a over 1, then 5a over 1. Since our a is negative 1, we're just going to put negative 1 over 1. So from here, we're going to go down 1 and over 1, down 1 over 1. Then 3 times negative 1 is going to give me negative 3 over 1. So from here, I'm going to go down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. I would do the 5, negative 5, but it's going to move off my graph, so I don't really need to do that. Okay, so this is going to be my wonderful parabola. Any questions over that? Okay, then the next thing we need to do is to graph this line right here. We're going to go, this is just like y equals -4. That's the same exact thing that's written. I'm going to go where y is -4, which is right here. Y is always -4, so I'm going to find another value where y is -4. And that would be somewhere over here. Over here also, y is still -4. The x value can change all of it all at once, but the y cannot change. So we're graphing a horizontal line. Where y is -4. Okay, so when we're solving this equation, I'm looking for a value for x that'll make this equal to -4. So what are my values for x when it's -4 for y?
-5.
So right here, looks like it's -5, right? It crosses at -5. So when x is -5, y is -4. Is there another value that'll make y -4? Yeah? Is it 0? I feel like it's -1. It's not on the axis, right? On the y-axis? It's over 1. It's right here. Also where x equals -1. So the solution to this equation is x equals -5 and -1. So that's where my two graphs intersect. Any questions over that? We're going to graph the next one now. Okay, we're going to do the same thing. We're going to graph this side. So we're going to graph f of x equals x squared plus 4x minus 5. And we're going to graph h of x equals the other side, which is 6. Any questions over that? So for this, I would change this into vertex form because that makes it easy for me to graph. So I'm going to complete the square. Remember, I'm going to draw my little boxes. I have x squared goes here. Then I need to make my rectangles. There's 4 x's, so how many do each of my sides get? 2. I'm going to draw a rectangle here, and then a rectangle here, and then here, and then here. So my side's length is going to be x plus 2. Okay, and this would also be x plus 2, which gives me x plus 2 squared. Now, how many little squares am I short? I'm short 4, right? And I'm already missing how many? 5. So I'm missing 9, right? So I have f of x equals x plus 2 squared minus 9. Any questions over that? Okay. So my vertex here is at -2 and -9, which is kind of rough because it goes off my graph, right? So I'm going to -2. I'm going to go where x is -2 and y is -9, so we're just going to have to add those on. Sorry, guys. Then I'm going to use my a value. My a value is right here. It's 1. So I'm going to go a over 1, and then 3a over 1, and then 5a over 1. So I'm going to go from here. I'm going to go up 1 over 1, up 1 over 1, then up 1, 2, 3, and over 1, up 1, 2, 3, and over 1. You see, I missed it. Then I'm going to go up 5, 1, 2, 3, 4, 5, and over 1. Up 1, 2, 3, 4, 5, and over 1. Then I could go up 7 and over 1. So it'd be up 7 and over 1. Up 7 and over 1. So this would be my beautiful parabola if I can make it really pretty. This one's a little bit off because it curves too much for me. Any questions over that? Okay, now I want to graph the h of x equals 6. So I'm going to go where y equals 6. And I'm going to find a bunch of points where y is 6. Now yours are probably a little bit more accurate than mine. Wonderful graph because it curves so much here. Let's see. I can't make it any better with this thing. It's too hard. So where does it look like it crosses at 6? It kind of in the middle, right? It's kind of not really on a number. You'd have to estimate it's kind of around between 1 and 2, right? And then -3 and -6. Somewhere between here and here it crosses up here. And somewhere between 1 and 2 it crosses up here. Okay? This is the problem with solving quadratics with graphing, is we wouldn't get a number here. We'd get an estimate. We'd have to estimate what that is. And it depends. Obviously mine is going to be way off because my graph's way off, right? Depends on how amazing you are at graphing. Okay? So this is why we need to learn how to solve it algebraically. Okay? Because we're not sure what this is. I don't really know where they're crossing. So we'll put question marks there. So somewhere over here is where they intersect, and here. But I'm not quite sure where that is. My question marks. So we're going to learn how to solve this algebraically so we can get an actual value. Before we do that, we need to have some vocab. Okay, the zero product property is just anything times 0 is 0. Okay, anything times 0 is 0. So 5 times 0 is 0. 3x times 0 is 0. X squared minus 5x plus 2 times 0 is 0. Okay? That's what the zero product property means. Intercept form is what we know as factored form right now. So last unit, we talked about this being factored form. This is actually intercept form because you can easily see the x-intercept, which is x, which is -4 and or -3. Rechange the sign. Okay, so today we are solving quadratic equations. Okay, solving a quadratic equation, what we're actually doing is looking for the x-intercepts. So there's a lot of words they'll use for the x-intercepts. They'll use the roots. They'll ask you to find the roots. They'll ask you to find the zeros. They'll ask you to find the solutions. Those are all the same thing to find the x-intercepts, where it crosses the x-axis. It all means to solve. Solve this quadratic equation. Any questions over that? Okay. So if they're asking you what are the solutions and we're looking for the x-intercepts, all we're going to do is separate our factors, set them equal to 0, because one of these two factors needs to be 0 in order for your answer to be 0. That's the zero product property. One or both of them need to be 0. So what value for x would make this 0? Very good, x equaling -7. And what value for x would make this 0? X equals 3. So that is the solutions, or the x-intercepts, or the roots, or the zeros for that quadratic function. Any questions over that? Okay. So this first one, we need to factor it in order to solve. So we're going to follow these steps. We need to write it in standard form and make the equation equal to 0. This is already in standard form. The x squared, then minus 10x, then minus 24, that's standard form. Okay, the only thing we need to do is change the f of x to 0, because we're looking for the x-intercepts, and that is where y is 0. So everybody factor this for me. Okay, Oscar, what did you get for your factors? So 12 and 2. Which one needs to be negative? Very good. So in order for these two to subtract to 10, the 12 needs to be the negative 10, the 12 needs to be negative. and then the 2 needs to be positive. How many of you guys got 6 and 4? Okay? My issue with 6 and 4 is this tells me I'm subtracting, and 6 and 4 add to negative 10 and do not subtract. Okay? If you put 6 and 4 here, negative 6 and negative 4, negative 6 times negative 4 would give me a positive 24 here. And I don't have a positive, I have a negative. Okay? That's a common mistake. So it's very important that you're checking your signs. So my factors are x plus 2, and x minus 12, and it equals 0. Now I'm going to use my zero product property to set them equal to 0. X plus 2 equals 0, and then x minus 12 equals 0. So I'm going to subtract 2 from both sides. I'm going to get x equals negative 2. I'm going to add the 12 to both sides. I'm going to get x equals 12. So my solutions, or my x-intercepts, are negative 2 and 12. Any questions over that? Okay, next one. Before we can solve this, we need to put it in standard form and make the equation equal to 0. So that means I need to move the 12 over. So I have to subtract 12 from this side. If I subtract 12 from this side, I also have to subtract 12 from this side. So that gives me 3x squared minus 16x. None of these are like terms, right? Can any of those be added together? No, so I have a minus 12 here, and that equals 0. Now I need to factor this. Okay, everyone factor it. Okay, Marissa, what'd you get for your factors? What'd you get for your factors? What? So this would be 2x here. This would be 3x times 2 would be negative, or sorry, just 18x. Oh good. If I subtract them, will I get 16? Which one needs to be negative? 18 needs to be negative. The 2 needs to be positive. The negative 18 plus 2 is negative 16. So the 6 needs to be negative and the 2 needs to be positive. So my factors are 3x plus 2 times x minus 6. We're going to separate them and set them equal to 0. Okay, this one's a little trickier because it has that 3 in front. You're going to solve it the same way you would solve any basic equation. You would subtract 2 from both sides and perform your opposite operation. Then the 3x, it's being multiplied. So what's the opposite of multiplying, class? Dividing. So you want to divide both sides by 3. So you would get x equals negative 2 over 3. That's one of your answers. This one will be easy because you can just add the 6. And you're going to get x equals 6. So here's the other answer. Any questions over that? Okay. Okay, you guys do the next one on your own. Okay, so our answers, most of us got. Your factors should be 2x plus 3 times x plus 5 equals 0. Sorry. So then you have 2x plus 3 equals 0, and x plus 5 equals 0. You're going to subtract 3 from both sides. You're going to get 2x equals negative 3. You'll divide by 2. Divide by 2. You're going to get x equals negative 3 over 2. Here you're going to subtract 5 from both sides. And you're going to get x equals negative 5. So your two x-intercepts are negative 5 and negative 3 over 2. Any questions over that? Okay, this one you'll do the same thing. You're just going to subtract 12 from both sides because you need it equal to 0. So to make that equal to 0, you got to take away the 12. And if you do it to one side, you have to do it to the other. So you're going to get 0 equals 6x squared minus x minus 12. Can everybody factor this for me?
We didn't.
So what were your factors, your length of your sides? Okay, so what did you get here? 2x and 3x. Very good. Okay, then what did you get to multiply to 12? 6 and 2. So the 2 has, well, you can't do 6 and 2 because if I put a 6 here, then they have a GCF, and I can't do that. So what's something else that multiplies to 12? 4 and 3. Okay, so what goes here is 3 times 3, which is 9x's. What goes here is 2 times the 4, which is 8x's. If I subtract them, do I get 1? And then which one needs to be negative to get, very good, the 9 needs to be negative. And the 4 needs to be positive. So my factors need to be 3x plus 4, and then 2x minus 3. So when you solve this, you should get x equals negative 4 over 3 and positive 3 over 2. Any questions over that? If we can't factor something, then we need another way to solve it. Okay, yes. So we're going to do it by finding the square root. Okay, if it's in vertex form, which is what these other ones will be in, I can solve it by square rooting it. Okay? So let's see how we do that. So the first thing we need to do is isolate the x squared. We need to get this x squared all by itself. So Jasmine, how am I going to get rid of the negative 100? Very good. We're going to add 100 to both sides. That's going to give me x squared equals 100. Lauren, then what should I do? Do you know how to get rid of an x squared? No. Okay, so this is kind of important. The opposite operation of squaring something is square rooting. Any questions over that? Okay, so if I want to get rid of the x squared, that's what we're going to need to, that's why we reviewed at the beginning, how to square root things. Okay, in order to get rid of the x squared, we need to square root both sides. And the square root of x squared is just x. Because the length of my sides, the area is x squared, so the length of the sides of that square is going to be x times x. Okay? Very good. The square root of 100 then, my length of my sides would be 10. Okay? When we're solving, though, an equation that we have to take the square root of it, we need to also be aware of another number that's going to multiply to 100. What other number times itself will give me 100? 25 times 25 will be 625. We're multiplying. Anyone have an idea? Negative 10. Negative 10 times negative 10 will give me my positive 10. Okay? Very good. Okay? So when we're solving, we need the 10 and the negative 10. Because I don't know which value they use for x in order to get this equation. Okay, next one we're going to do the same thing. We need to get that x squared by itself. We're going to set it equal to 0, because when we solve, we always set it equal to 0. Because we're looking for the x-intercept. You need to add 49 to both sides. And I get 49 equals 9x squared. Very good. I still need to get that x squared by itself, so I have to divide by the 9. So I'm going to get 49 over 9 equals x squared. Now I can take the square root. Okay, even though it's a fraction, I'm going to just take the square root of the top number and then the square root of the bottom number. So class, what's the square root of 49? What's the square root of 9? Okay, but that could be a positive, or it could also be negative 7 over 3 times negative 7 over 3 to get the positive 49 over 9. Okay. Okay, this looks like more like vertex form, correct? Or vertex would be -7 and -64. Okay, so here's how we would solve it. It's the same way we're doing here. The only difference is the squared, isolate the x squared. This whole thing is squared, so we need to isolate this whole thing. We need to get that whole x plus 7 squared by itself. Okay, we want it equal to 0 still because we're looking for the x-intercept, which is where y is 0. So we have to add 64 to both sides. And I get 64 equals x plus 7 squared. Now I'm only left with the squared thing. So I have to undo that squared thing. Class, what's the square root of 64? 8 and what else? -8. It has to have both. Give it a second, it's thinking about, oh, there you go, -8. Now, what's the square root of x plus 7 squared? What are the lengths of the sides? If the area was x plus 7 squared, what would be the length of the sides?
1 and 7.
X plus 7 times x plus 7. So it's just x plus 7. It just undoes that square. Okay, x is not by itself, so now I have to subtract that 7. Since I have two answers here, I need to subtract 7 from 8 and from -8. So 7 minus 7 is 0, and I get left with x. And then 8 minus 7 is 1. And -8 and -7 is -15. Good. Any questions over that? Okay. I'm going to do I with you, and then I want you to do H. So I'm going to solve this. Again, I need to get that x squared by itself. So the x minus 2 is all squared, so I have to isolate that whole thing. I'm going to add the 24 to both sides. I need to get x minus 2 squared, and it equals 24. Okay, again, it's by itself, so now we have to square root it. And then x minus 2 squared is just x minus 2, and we take the square root of it. The 24, we don't have a perfect square, so we have to factor it like we did at the beginning of the note. You have 2 radical 6? Very good. So let's just prove that here. I'm going to get x minus 2 equals, I have a pair of 2's that are on the outside, for the length and the width, and the 2 and the 3 have to be split up. Okay? So inside the radical, I have a 2 and a 3, which is the square root of 6. But I don't just have 2 square root 6. I also have a negative 2 square root 6. You just put the 2 in front, because you can't have a negative inside the radical. Because a negative times a negative is a positive, right? Okay, so we're going to add 2 to both sides. Now, I already talked about this as well. Are 2 and 2 radical 6 like terms? No, so you just put the 2 in front, and you add 2 radical 6. And then you have the 2 in front, and you subtract 2 radical 6. This is a 2, just so you know. So those are my 2 solutions. Yes. Because you're adding 2 each time, right? So this 2 is positive. You had to get rid of this 2 here. Okay? So the only thing that's going to be negative is things that we had to take the square root of, the 2 radical 6. Any other questions? Okay, let's go to the back. We'll skip it. I do need to do O for you, though, because this is in your homework, and I want to make sure you know how to do it. Okay, so again, we need to set this equal to 0. So we're going to subtract 49x from both sides, because it needs to be equal to 0. Now, 21x squared and 49x, they're not like terms, because they don't have the same exponent. So don't try and add them. Just stick them next to each other. Do 21x squared minus 49x. That'll equal 0. Now, in order to factor this, you need to factor out the GCF. So what can they both be divided by? 7 and what else? Very good. They both have an x, so pull out a 7x. Then 21 divided by 7 is going to be 3, and x squared divided by x is just x. And then 49 divided by 7 is 7, and x divided by x is 1. So my factors are 7x times 3x minus 7. It equals 0. We're not done because we haven't solved it yet, right? That was just factoring it. So now we have to separate our factors and set them equal to 0. Use our zero product property. Okay, so here we're going to divide by 7, divide by 7, and I'm going to get x equals 0 divided by 7 is 0. Okay, if I have 0 things, but I have 7 people to give it to them, what do we all get?
0.
We all get nothing. Okay, so everyone gets 0. So I add 7 to both sides here. I get 3x equals 7. I divide by 3, divide by 3. So I get x equals 7 over 3. So there's my 2 solutions. Any questions over that? Okay. So I now need you guys to do the following 3 questions. Write an equation in standard form that you can solve by factoring. So I want you to tell the difference between a problem you have to factor versus a problem you have to square root. So here you're going to write a problem that you can factor to solve it. And here you're going to write a problem where you're going to have to square root to solve it. Okay. I would prefer it original. I want you to work backwards. You can use mine as ideas, but don't just copy one of mine. Okay, Lauren, what was your equation that you could factor? And we want it equal to 0 or f of x equals something like that. But that's good. You can factor that. Okay? Peyton, what was your equation that you wrote that could be solved by square rooting? 2x squared minus 12. Okay? That is one that you have to solve by square rooting. Okay, notice the big thing that you can tell between one that you're going to have to solve by factoring versus one you're going to have to solve by square rooting is that one that you're going to solve by factoring has to have an x. not just the x squared. So it has an x squared and an x. This one will just have an x squared. It won't have that middle term of an x somewhere. Yes? That's fine too, right? You can do f of x equals whatever it is that you want it to be. Okay? Last one, when we solve quadratic equations, why do we set it equal to 0? Yep. Okay, to solve it. Okay, but why 0? Yes.
Because we also find, the way you find x5 is such that its y value is 0.
Okay, and why is the y value going to be 0? It's on the x-axis. Okay, that's the key. You're setting it equal to 0 because you're finding the x-intercepts. And on the x-axis, y is 0. Okay? So you need to have something about looking for you're finding the x-intercepts. Okay.